Welcome back. This is Joel, and we'll talk about Docker, right, in this video and probably subsequent videos as well, right? So if you go back to my channel, right, you will find a separate section which is devoted mainly for network automation, right? And I talk about a bunch of things here, which I personally have used over the years, right? Maybe Ansible, maybe Pioneers, Netconf, Yang, and so on, right? And personally, whenever I write scripts, right, or whenever I try to automate something, I start by writing a script, right? And I'm familiar with Python, so I write a Python script, right? And I'm pretty sure you guys probably are familiar with different programming languages, and you might be running something with that. You might be running something with Go, right? Or you might be running with different languages out there, right? um, which is good, right? But what's the next step? I mean, do you want to just go about writing single scripts and like scatter it all the place, or do you have a use case where you want to kind of package it together, right? Do you want to kind of package it together so that you can then share it with someone else, right? And they can just run it without the overhead of kind of setting up the environment and doing a lot of hassle, right? So I personally feel that's where Docker kind of comes into play, at least from a from an automation perspective, from a network automation perspective, right? Where you might be writing a bunch of scripts, you might be doing a lot of automation, but how do you package it? How do you do a small MVP, right? How do you create a small piece of software? So yeah, Docker really helps there, right? And I think I have a small so this is picked directly from the Docker website, right? And there's a nice infographic here talking about what is a container, right? What's a Docker container? What is it to begin with, right? For folks who haven't come across this, I mean, if you have done your Cisco DevNet, it talks a little bit about Docker, so you should be well versed with it. But otherwise, for people who are hearing it for the first time, it's very similar to virtual machines to begin with, right? If you don't know container, if you don't know Docker, if you have not heard of containers before, I think you will resonate very well with virtual machines, right? So what you have on the right side is a virtual machine. You have your infrastructure, you have your host, and then on top of that you run a hypervisor, right? You have your VMware hypervisor, so you can run KVM and different types of hypervisors. And on that we spin up different virtual machines. So each of the virtual machine will internally have its own guest operating system, right? And on that guest operating system, you'll basically end up running your apps, right? Now that's where your containers differ. With container, what you do is you still have your physical hardware, your laptop, your server, whatnot, right? And then you have the host operating system, right? And the kernel of that operating system is kind of shared across all the apps. So each of the app, again, now you want to run a different app, you see you don't have a guest operating system here. So containers are very lightweight because of that, right? And obviously everything, each of these processes, they kind of each of these apps are going to remain isolated from the other. They'll have their own networks and everything, right? The only difference, or the major difference being, I mean, obviously there's a lot of difference from a internal standpoint, right? From a technical, but we can kind of bypass that for now. If you know virtual machine, if this should be one takeaway, right, from this video, that remember, in your containers, right, each of the container, it kind of leverages the underlying OS kernel, right? It doesn't have its own operating system like a guest operating system like you see here on the virtual machine, right? Do go read a little bit about Docker and stuff. I mean, I'm not trying to kind of do Docker from the basics perspective. Let me actually tell you what is the agenda, right? What I'm trying to accomplish with this video and maybe subsequent videos. So like I said, we build a lot of as network engineers, we build different kind of scripts, right? We do different kinds of automation. Now my main objective here is to take one of that script, right? To take any kind of script, right? It could be probably something which is just collecting some show commands from a device, right? Or anything, right? To take one of that script and kind of to build to containerize it basically, right? And to kind of add some features around it, right? So that's the main objective here. So that's what we are going to get going with this particular video. All right, so let's start. Okay, so what do we have? So this is basically www.docker.com. This is where you get all the information you need. You have nice documentation, right? You can go to developers, you can click on docs, and it will basically throw you, I think, to this page, and it gives you very good documentation as well. They themselves have some tutorials on how to run probably a Node.js app, right? As part of their getting started guide, you can go ahead and check that out as well. But some of the prerequisites is, one of the things is you need to have Docker desktop, right? So on your laptop, I'm assuming most of you are probably playing around, testing these technologies on your laptop. So you would basically need a Docker desktop, and you can download the right version, whichever you want, right, from here, depending on your operating system. So once you have the Docker desktop, I don't know if I've already spun it up. I think it's probably here. So let's open that. So this is how it shows up, right? Did it? Okay, there you go, right? So this is how your Docker desktop looks like, right? It basically is a one-stop place to look at all the containers, all the images, are there any volumes hanging from it, and so on, right? So all of this you can see in one single place, and that's basically your Docker desktop, right? This is very much important. I mean, this is kind of instantiating the Docker environment in your laptop, right? So having that is important. Next, I mean, since what we are trying to do is we are trying to take a simple script and kind of containerize it, right? We are kind of converting a script, a single individual script, into a container. Obviously, we want some editor to code with, right? And I use the Microsoft Visual Studio, right? I don't know which version is this. Maybe if you click on this, okay, there you go. That's the version which I use, right? The Visual Studio Code. But I think some of you might be familiar with PyCharm, right? That's also a very famous Python IDE, and you can use that as well. Only difference is your Visual Studio is open source, whereas PyCharm, I think you have some community version and so on. But obviously, you will have to for a full-blown access, you will have to obviously purchase the license and so on. Whereas Visual Studio is open source, right? You can use it. So that's what I use, right? So this is place. I think you probably would have seen me using this probably in the previous videos as well. Okay, so that's the second thing, and I think we are good. So now what we'll do is let's start with something basic, right? So let's actually do a little bit of hands-on right now. Okay, so we are starting by creating. So right now I don't have anything. What do I have? I just have a folder created. So this is my workspace. You can also create a workspace, over here, right? You can add a folder to the workspace and so on. Workspace is nothing but, it's more like a working directory, of your project, right? It's not mandatory. I like to organize it this way. So this is my workspace. So everything what I do is going to be part of this. Okay, cool. So what we are trying to build, like I said, we are trying to build application, right? We are trying to build an application using Docker, and that application is basically nothing but a simple Python script which we are converting into a web app. It's basically going to be a web application, right? And in a web application, generally what you're going to have, let me see if I can write here. Yeah. So in a web application, you're going to just have a front end generally, right? You're going to have a back end, and then you're going to have a database layer, right? More like a three stack. It's like the it's a traditional web app, right? So the front end will talk to the back end, and the back end will be able to talk to both front end as well as the database. So this is generally the so this is generally, database also probably will talk to the back end, right? So it's just it's a three-tier architecture. It's a very traditional web app, right? We'll talk about this more as we get to it, but yeah, that's what we are trying to achieve. Okay, cool. So that being said, so I have a folder, and I basically have the source code in that, but I still don't have Python, right? Before we get to the container part, what we'll do is we'll actually spin up our Python script and we'll run it. But to do that, we need Python, don't we? So let's get to my terminal. You have terminal actually inbuilt inside your Visual Studio, right? You can just click on terminal and new terminal, and the terminal spins up here. But I like using my separate item, so I basically use like this. You can use it whichever way you prefer. Okay, so this is my directory as of now, and what we will do is first let's check, do we have Python? So I'm using Python 3.9.6. okay, so that's probably the latest version in 3.9. You guys can use probably the latest one where the latest one when you are watching the video, but this is the one which I am running. So that's my Python, but I don't like running the Python directly from from the default installation, right? So I like creating what we call as virtual environments, right? Let me tell you, and let me actually show you how to do that, right? So this is my folder, and inside this, think of virtual environment as creating an isolated Python environment inside a directory, right? Or for a particular project. So I'm going to spin up a new Python environment, and that will be used only for this project, right? So whatever pip installs I do and everything will be isolated to this environment itself, and it will not affect my other environments, probably a bunch of other projects where I'm working on. Cool. So how do you do that? So let's run Python, right? And then there is a module called VNV. Okay, Python. You have to call the module, and then the directory name, right? You can give any directory name. I'm just going to use the name of the directory as VNV, but you can give any directory name actually, right? So there you go. Hit the enter. It's gonna take few seconds because it's going to. There you go. It's done. But it has basically used the Python. It has basically gone and created. So this was my default Python, which is running. It's more like the Python which is running on the operating system, the main instance of it. But I just went and created a copy of it, right? So how do you initiate this? So you'll have to just say source. You'll have to source a particular file, right? So we just now created this particular folder, right? VNV, and inside that folder there will be a file called activate. So you have to get to that and you have to source that, right? So you're gonna source it, and once you source, you see your environment kind of changes here. So that means you're inside the virtual environment. Awesome. So now we are inside that. We can double check, and there you see we have 3.9.6, very same as my global Python. I've just created an isolated environment inside my directory. Okay. All right. So that's good. What else? So we have installed that. The next is let's go back to my Python directory, right? So there you go. This is the folder which got created because I installed Python. So all the Python related stuff is inside this, right? You can see pip and everything is there. So not much use to us. Let's close this directory for now. Let's concentrate on our source code, right? Because like I said, we are going to do this step by step, right? Step number 1, we are going to run our Python script, right? Without any Docker, without any container, right? Directly going to run the Python script, make sure it is working. Then we will approach the major agenda of this video, which is containerizing it, right? Cool. So one of the simplest example which many people use while talking about the Python application here is a Flask application. So I'm going to use the same thing as well, right? So look at my directory structure here. So I've got the Docker web app as my super parent directory. Inside that I have a bunch of folders called net DevOps, and this is my first video on the whole Docker space. So I'm going to say 1-container. Maybe if I make more videos and more topics in container, I'm going to call this as 2-3 different lessons, right? We're just going to put a serial number so it's easier for people to understand. Then what we are creating here is we are trying to create a app, right? We are going to create an app. I'm going to call that as a network app, and this app is basically going to think of it as a small app which keeps track of the network devices, right? More like an inventory tracker, right? Very simple. I mean, I'm not trying to complicate here with taking a huge complicated app. I'm just trying to keep it as simple as possible, because the whole idea of this video and probably the series is to talk about Docker more, right? And not much about Python and the underlying code behind it, right? So that's not the objective. The objective is to talk more about Docker. Okay, cool. So that's my directory structure, and inside that we have a source folder. Let's click on the app, right? And that's where we've got the file, the Python file, and this is the piece of code which I was talking about, right? And before looking at this code, let me take you back to the documentation. I think I might have opened the documentation of something called as Flask, right? So some of you might have used Flask before, right? And some of you probably wouldn't. Probably you guys have used something like Django, right? And so on, right? So there are different kind of frameworks, right? Don't get too confused or too overwhelmed seeing these names, right? It's actually pretty simple, right? Flask is, think of it this way. I mean, I personally use Flask a lot because whenever I write a script, right, I write a plain Python script, and if I want to add web service to it, right, if I want to add a front end to it, if I want to basically build a web page, right, and if I want to do that within Python, I think Flask is one of the easiest way to do it, right? I wouldn't say the most efficient and the most optimal, because there are other frameworks out there which are more strong, and which come with a lot of other features. But if your use case is something very simple, to build a very simple kind of like a web page with a very basic view and so on, I would say Flask is your first attempt, and that's why you see right on the user guide they call it as, it's, I think it's called micro framework, right? It's a micro web framework, which is written in Python. It doesn't provide you like a lot of, see, they're calling it as micro, right? Because the reason is because it doesn't provide you great, like for example, database abstraction layer, right, or form validation and stuff like that, right? Especially people who build websites will kind of resonate with these terms, but it doesn't provide like all those capabilities inbuilt. You can always use them, right? You can also always import third-party libraries and get those facilities or those features, in your app, but it doesn't provide natively, right? But it, at the same time, it provides some of the most important features which are more than enough for you to get started with an app, right? You can read more about Flask. I mean, I think technically this itself is a very small documentation, and you'll be able to kind of get it going. It's pretty simple one. I think they might have a minimal application example as well. Technically, see, these 4 lines or 5 lines of code is enough for you to run a web application in Python using Flask, right? That's why it's very simple, it's very minimalistic, and it does the job, right? So we are going to use this, and what we are going to do is we are going to create we are trying to create a web app which will which will try to keep track of the network devices. We are just kind of host names mainly, right? We are just trying to create a web service which will keep a track or list out the network devices in the network, right? So that's what we're trying to do. Okay, so let's come back. So now we can look at the code, right? So that's the application, right, which we have. Like I said, I mean, you don't have to really stick to this application, this piece of code, right? This is just an example. Like I said, there are hundreds of similar examples on the internet. People using Flask or different different language itself, right? I mean, you don't really have to even use Python. You can use anything else. But the main intention of this one is to kind of the whole idea is to look at the Docker piece of it, right? Not the Python part. But anyway, since we are on the page, let me spend a couple of minutes here, right? What we are trying to do is all the imports are happening on the top, and as of now, right, this is a single script, so I don't have a separate database, right, to begin with. So the list of devices in my network, as of now, it is kind of added to a list right here, right? So the list has been defined at the top, and we have the devices. We have 2 devices as of now, right, added to the, so that's why I said, right, the script, or basically the function of this application is to keep a track of the devices in the network. Every device will have an ID and the device name, right, or host name basically, right? And then you have to instantiate that Flask, what we imported here. You have to instantiate with the name of the package of your, or name of the module, right? Underscore name. I think if some of you know, it is basically one of those variables which is kind of instantiated when a piece of code runs, right? Generally, underscore name equals to the main, right? If you're running this code directly from here, you can see here, this variable will always be equating to the main, right? This is again Python. I'm not getting too much into that. I'll not get into that. But yeah, that's mainly that. And then you have a bunch of functions here, right? You might, if you have not come across this app.route, right? What is this? Is this Python? Yes, it is Python. It's basically called as decorator, right? It's a decorator which is again defined inside Flask, so you don't have to. What you need to do is um, what is the main objective of Flask? Like I said, it's a web development framework, right? So what do you have when you're building a website? You have a lot of URL redirections, right? You would want the user to, I don't know, probably list out the devices. So you would basically say IP address slash, right, devices, and then you would get the list of devices. Or you would want to kind of um, uh, this would basically get a single device, right? Instead of getting all the devices, you want to get a single device. So you would probably hit this endpoint. You would probably want to update the list of devices, right? You would probably want to kind of yeah, this is update, this is add a new device in itself, right? And then you would want to delete the device. So these are different functions, which are doing that job for you, right? So it's a very simple application. Like I said, don't concentrate too much on the Python part of it, right? It's a simple Python. I think if you look at the code, you will basically end up getting it. But the whole idea is to kind of see how Flask is used here, to kind of build a simple application which will kind of list out the devices in a network, list out details of a particular device, or maybe you want to add a new device to the inventory, right, which you are maintaining, or probably update the device inventory, or maybe delete the device, right? At the bottom you can see this Flask application. There's a nice feature of Flask. It's called debug feature, right, which means you can run Flask. When you run Flask in debug feature, it will auto reload even if the application is running, right? Let's say if I do app.py, if I do python app.py, and this script is running, and in the middle of the code execution, even if I go and kind of change something here, right, the script will auto reload and it will run the new fresh code, right? So that's pretty cool feature. So if for to doing that, you need to run it in debug equals true, right? And then like I said, I'm doing all my development on my local laptop, so I'm going to run it on the local host. So that's why it's 0.0.0. All right, happy with that. So what we will do next is, let's run this code, guys. It's pretty simple. See, now we have got it into our we are inside our Python environment which we instantiated, right? So but before running that, let's also look at one more important thing. I said we are going to use Flask, but do we have Flask as of now? No, we don't have Flask, right? So in a traditional code, in a traditional way of code development, right? People add a file called requirements file. So you can do all pip installs from here. So let me show you how that is done. So let's do pip install, right? Okay, pip install, and there we go. I think I've done this before. Have I? Have I done that before? Yeah, I've done that before. Okay, so that's the same thing. Okay, so pip install, and you need to put the -r flag, and you need to call that requirements.txt file, right? My requirements.txt file is over here. You need to put the path of your requirement.txt file. Okay, so let's hit enter. So what it's going to do is, okay, so give it a second. I think my internet is down. Okay, I think I have a mistake in the name of the folder here. So let's do it step by step. So let's do pip install /-r. Let's get into the folder net DevOps, one container, right? Let's do network application, and then I believe it is yeah, there we go. So that was the mistake, right? So that's the old folder which I was referring to. I've changed the name of the folder, so it's actually device service, and then you have the requirement.txt. Okay, there you go. It's downloading Flask, and it installed the Flask, right? There we go. That's it. That's the only requirement we have. So now we should actually be able to run the script, right? So to run the script, again, we will have to get into this whole, let's get into that folder. So it's only net DevOps, I think it's device service. Let's get into that, and then we probably have something called source. Okay, and in that we have the file called app.py. Okay, are we ready to run? I think we are. There we go. Right, so our script is running now. Okay, how do we test this? So to test this, like I said, I think I have a couple of curl commands here. So let's test this, right? So let's test. So currently our database has two devices, right? Device 1 and device 2. Let's see if that works. So I'm gonna do, there we go, right? So we have, I don't need to do in verbose mode technically. but I just it just gives you a lot of output. So let's just remove the dash v. Okay, there you go, right? So we did a curl, and always remember by default Flask runs in, even if you don't provide the port number, it runs in port 5000, right? So that's why you can see me doing a curl to port 5000, right? And I'm hitting the endpoint which is devices. That's why it's listing out the 2 devices. Got it? Second endpoint, let's run something else. So there you go. We listed out the total devices. Next is we want to list the details of one single device, which is device number 1. So we're gonna hit that ID, and there you go. It gave me details of that single device. Right? Cool. That's nice. What other endpoints do we have? We have an endpoint here to kind of, this is a little lengthier endpoint because it's a post command, right? For post command, you'll be sending some data, right, in post. And because of that, you need to tell what kind of data, the content type has to be mentioned. Otherwise, the request will not go through. So what I'm doing here is I'm adding a new device, right? We had device 1 and device 2. Now I'm basically going to add the third device, and the device got added. I can rerun the previous, slash devices endpoint, and there you go. Now the number of devices have increased to 3, right? So we're just testing these endpoints which are taken care by the code, right? We can probably update our device as well. Let's update the device number 2. Okay, so we updated the device 2. The device was earlier called device 2. Now it is called updated device 2, right? We can again run this, and you can see the changes happening shown here, right? Probably the last one would be delete the device. Does this work? I think it should, right? So we are basically going to run the same curl command, but with the delete method, and we are going to delete device number 2. There you go, it got deleted, right? Let's see, there you go, right? We now have device 1 and 3, right? Which means that our web app is working fine. So we have successfully created a simple Python script which is keeping track of devices, right? In your network probably. Doesn't even have IP address. It's very simple. It just has an ID and it has the host name. That's it, right? Nothing special at all. I mean, that's why I said, the script can be anything. You can pick, there are like thousands of examples out there. You can pick any script, or probably you can use a script which you guys probably built, to do something recently, right? So that should do as well, right? But Flask is a very good example because you have the ports and all of that, and you will get to see how it really works. Okay, so there you go. So that's done. So we have successfully run a simple Python script. Now the next important part, right? This is where the whole Docker piece comes into play. All right. So I probably forgot to mention this earlier. The other important thing is, once you've installed your Visual Studio, it's better to download some of the extensions, right? For example, the extensions which I use are, I think it's Python. So you can basically go and download the Python extension, this one, and then probably it's also better to have Docker, right? So you have an extension for Docker as well, pretty useful, right? You can get these both downloaded, okay? So that once you do that, right, your Docker file and all will appear with the right symbols, and it will be easier for you to kind of do the development, right? Cool. So that being said, we have successfully run this, right? Let's go back here. So we ran that. Let me stop that script. We no longer need it running. Let's come back here. So what I've done now is I've added a file called Docker file here. But before getting to that, let me actually tell you what it means, right? So I think it's very important to understand basically the Docker lifecycle kind of thing, right? So I think, there are a lot of things in Docker, but I'm just going to concentrate on the stuff which we would need, at least in this particular video, or maybe from a general use case perspective, right? So the Docker file is probably the very first thing you need to understand, right? So the Docker file, think of it as this way, right? It basically has a bunch of instructions, right, which will tell the Docker engine to kind of create what we call as an image, right? So the output of this is nothing but an image, right? So it will have a bunch of instructions to create what we call as, actually not just an image, we call it as Docker image, right? So Docker image is created. So Docker file has the instructions, and Docker image is basically kind of like the outcome of that, right? Now the Docker image also is nothing but it's again it's a template, right? And it was formed out of the Docker file, right? But it is not running yet, right? The image can be anything. It can be a Ubuntu image, it can be a Python image, it can be a Debian image, whatever it is, right? It is also nothing but a bunch of instructions, which obviously is an outcome of the Docker file, but it is not running yet, right? So you have created the image, great, and this image obviously will be stored in your Docker, local, the Docker instance, basically the Docker desktop where I showed you earlier. But to get it running, right, that is where you need to kind of run that image, and that's where you get the final outcome, or the final piece to a puzzle, which is the Docker container, right? So I would say container is nothing but a running instance of this image, right, to put it simply, right? So this is how it actually flows through. You have a Docker file, then you first build the Docker file, that's where you get the image, right? So once you get the image, you can keep the image as is. This is like an intermediary step, right? Maybe you can build the Docker file, go get some coffee, right? So by the time the Docker image would have been built, and once the image is built, let's say you're now happy, you've got some time to work, right? You can quickly come and run the Docker image, and you would get the container up and running, right? So that's the workflow. So that being said, for our use case here, I have created a Docker file, right, which will in turn create an image and then a container, right? So let's look at that. So that's my Docker file, and see the path where it is stored. It is stored inside this device service folder. Okay. Now you have Docker file is something which you have to write. You have to write as per you can't write it in your own way, right? You have to write. It's nothing but an instruction. So Docker needs to understand this, right? So the container engine needs to understand this to create your images. So you need to write it in a certain way. This just is probably having 3 or 4 instructions, but there are a lot of other instructions which you can give, and you can check that out on the Docker's website, on the documentation. You will find a lot of other keywords which you can use to do a lot of different other kind of use cases, right? From our perspective, our use case perspective, I wouldn't think we would need anything else. So let's look at this. Okay. So first thing, before getting to this, I think it's better to have a quick look at what we call as the Docker Hub. I don't know if I have a link open to it, probably here. So this is your Visual Studio. I have a link open just to show you where you can download it. And yeah, there you go. Probably not. This is my Docker Hub, probably not. Okay, let's get to hub.docker.com, right? So there we go. So we've got this is how Docker Hub looks like. I think you might have to sign in. Just create a account, right, with your email, and it will allow you to sign in. But this is Docker Hub. What it really has is it has a bunch of images, right? Images, basically there are some formal images, official images, right? For example, Python. Let's go to Python, and you would basically end up finding the very first one would be a official image. So you will have a tag called official image. So this is given by the official contributor of Python, right? And you can see it has like 1 billion downloads and so on. There are different tags by which you can download, or you can pull those images and use it in your development. And generally there is something called latest. Like for example, the latest now looks to be 397, which is fine. So that's the latest image on the Docker Hub, right? And they will also generally give you an example how to use this image. Like for example, here it says to use this image, you can, if you want to use Python 3, probably put Python ::3, and there you go. Single colon 3, and that downloads Python 3. Similar is the logic with Python 2 and so on, right? So this is just Python, but there are similar images. You see your options here. Yeah, you have thousands of different kinds of images, and then you also have images which are shared by developers, right? So image, you need to understand this one thing, right? Docker looks at images as layers, right? So it builds layer by layer, right? So you're going to pull this image into your development engine, and you're going to probably build something on it, right? And that's where the container comes into play. But once you kill the container, right, that the top level, whatever you have written, right? Whatever you created with that container, the application part, that part will be removed, that part will be deleted, but Docker again stores the image intact in the memory, right? So that it doesn't have to pull the Docker image again, right? So it can just use the image for doing something else, for building some more applications in future, right? So it's more of a layered approach which Docker uses when it comes to images, right? That being said, let's come back. I just wanted to show you how the hub looks like. But that being said, so I think the very first instruction is straightforward, right? Because that straight means that we are basically, starting with an official Docker image, so official image of Python, right? So that's your base image, right, from Python. So it basically means that it has to go and get the base image from Docker Hub, and that's when you say from Python, it basically picks the latest one. I think it will pick 397 or something, right? Next is we've got the working directory, right? We are basically gonna say, look, you need to create a working directory called /code. So once you download this image, the working directory will be /code, and then we are going to copy the requirements.txt, right? Just think of it this way. I mean, from now on, we ran the Python script here locally just to show you that the Python script works, but from now on we are not running Python locally at all. We are going to start running everything inside the container, right? So all the prerequisites for running this application needs to be sent to the container, correct? So that's why we are basically copying the requirements text file, right, which is one of the important part, and we need this requirements. Only then you can do the pip install on it. So that information is basically sent to the working directory. So we are already in the working directory, and we have sent, copied the requirements to the working directory. Then we are running the command, we are doing pip install. So every single step which we did here, right, to bring up this Python, so this is the pip install command, right? So every single command we just now did to run that, Python script, we can actually automate it. And that is basically nothing but a set of instructions which go inside the Docker file, right? And then you have the copying of the source code as well, right? Because the source code is present inside the source folder, so that gets copied to basically the app.py will get copied to the code folder here. And the last is we are basically telling how to run this Python script, right? So Docker goes about doing all of this when it basically runs the container. Okay, so I think that should be more than enough. I think let's go and start this, right? Let's basically run the same application now, but with Docker, right? So before that, let's also look at our Docker desktop. Where is our Docker desktop? I think it should be here. There you go. We've got Docker desktop, right? So right now there is nothing. Images, volumes, everything is empty. But let's see what happens once we get it running, right? So yeah, so let's get into the folder, which is I think it's netdevops, one dash container. I think it's network app, and if I'm not wrong, it's device service. Yeah, so let's go here. Let's do lsal, and there you go. We have this file called Docker file, right? So once you're inside the directory of Docker file, right? So this is where we'll run the first command, which is docker build. Okay, so we're gonna do docker build, and I mean my commands are showing up because I've done the same commands before, but that's the exact command which you need to run. So I'm gonna say docker build, right? -t. What is -t? Let's check, right? So if you don't know a specific this thing, the extension, we can actually always go and check, right? So -t basically stands for tag. So we are basically adding a tag to this image, which is -t, and the image will get a tag called device service, right? So yeah, that's mainly it, right? And we are basically telling this is the place where you want to run this container, spin up this container. So let's go, let's hit enter. Okay, there you go, it's trying to do something. Look, it is trying to load something from the Docker. It got the Python latest just now. Now it is running the requirements.txt, which means it installed the pip, then it copied the source folder, right? There you go, it's done, right? We literally created a Python environment inside a container and copied all the source code inside it, right? And we did that in what, like 11.2 seconds. Right? How quick was that? Next is, let's run some of the simple commands, right? Let's do docker images. And there you go, that's the image, right? And that's the name which we gave. We tagged the image earlier, and that's why you can see. There are no containers running now. You can do docker ps and you can see there is nothing. Why? Because we just built the image. Only after we run the image, only then we will basically be having the container, right? So actually, let's get to that. Let's do docker run. Okay, my command is already here. But let's go through this. -t will basically run this container in a detached mode, which means it will just run the container and give my shell back so that I can. It basically runs in the background, right? -p basically is for mentioning the ports, right? So what is happening here? Our underlying Python application is using the port 5000, right? We need to map that port to the port of the host, right? Because this container, where is it running? It's running on my laptop, in my Mac laptop, right? The port 5000 on the container is different from the port 5000 on my local host, right? But if I have to do curl from here, I'm doing that curl on what? The local host. So I need to open up, or I need to publish the port. I need to publish the port of the container and map it to the port of the host machine, right? So that's why this is. You don't have to use 5000. I can use anything technically. I can use 10,000 here on the left side, right? It's just the mapping which you need to mention. All right, so there you go. And the last part was obviously the image name, right, which you want to kind of spin up. So now we have the container running, right? We can double check that. We can do docker ps and we have the container running. You have some information called container ID. You have the image name here, right? What else do you have? You've got the ports, right? This is exactly what I was talking about. The host machines 5000 is mapped to the 5000 of the container, right? That information. This is for IPv6. This is for IPv4. This is for IPv6. And then it also gives a random name to the container. I believe you can also change this. I forgot the option, but yeah, you can obviously change this and give a name to a container. Let's keep it default, so it is using some random name for now. That's fine. But our container is running, guys, which is good news, right? Which means we should be able to test exactly the stuff which we tested earlier. But this time the difference is we are not testing it against the Python script. We are testing it against the app which is running inside the container, which is nothing but the Python script, but it is running inside the container, right? So let's test the same thing. Let's start with curl devices. There you go, right? It's running, it's still working. Remember, the Python script is stopped. We stopped it here, right? The Python script was stopped here, but it's still working because now it's working against the container, right? You can do all this. So you can go and get the specific. Forgot. Okay, what else did we do? Curl. I think we did v, and there you go. We can get the specific device as well, right? So you can do basically literally everything which we did earlier. Maybe you want to do one more, we can do that. Curl HTTP, and or maybe let's do the post one, right? So, or yeah, basically let's do this one, bigger one, just to show you that it's still working, right? So there you go. So we added a third device, and there you go. When we run the devices endpoint, we are able to get the 3 devices, right? So yeah, so that's mainly it, guys. I mean, okay, so now that we have checked that works, let's probably go and check what else can we do. So you might have a question. Okay, so the container is running, great. How do I get into the container, right? Good question. Pretty simple, right? You have a command called exec, docker exec, and the flag which you need to hit is -it. I stands for I think interactive, and T stands for TTY. It basically means that you want to shell into the container, but the important thing is providing the correct container ID. So I'm going to provide this one now, right? I'm going to provide that. I think I missed the space over there. Did I? I think I did. Okay, there we go. So that's the container ID. And once I provided the container ID, you need to provide the shell name, right? I'm going to go with bash. Okay, so I put that. Sorry. Let's remove the code. My bad. That's weird. Okay, give me a second. Okay, our code had kind of sneaked in there. Now let's see if this works. Okay, there you go, right? So docker exec dash it and put the container ID and bash into it. And there you go, we are into the container now, right? We are inside it. And this is exactly our instruction, right? Remember, we created the working directory as /code, and that is what visible here. It has dropped us into the working directory. We can do ls-l or ls-al to kind of understand. There you go, the app.py which we wanted to be ported, right? That's the application, and that's present inside the code folder. We also have the requirements.txt, right? That has been copied here successfully as well, as expected. Okay, and the other stuff, right? You can see if you want to see the / directory as well, right? This is your typical Linux environment, right? So it has literally created a small tiny Linux environment for you, installed Python for you, and kind of done everything, right? Which is needed. So that's pretty cool, right? Now the next part is, if you want to stop this container, let's exit out of here, right? You can use the same command with respect to the container ID, keep it as is, and then do docker stop, right? So docker stop and the container ID will stop the container. Okay, so once the container is stopped, you will not be able to run the curl command. There you go, right? Curl is no longer working. Why? Because the container has stopped, right? You can also double check it by doing docker ps. There you go. It's no container, right? So yeah, guys, that's mainly what I wanted to do was, since Docker is one of the very important topic in DevNet and so on, and most of you guys might be reading a lot of theory around it, but how do you really practically use this? So a very simple example which I wanted to show here, but if time permits, I'll probably add on to this, right? Add on some more stuff from my notes here, around Docker volumes, secrets, and so on. A lot of cool things which we can do with Docker. So I hope that was useful, right? What we did was, we basically took a simple app of this sort called app.py. We ran it in Python first, and then we kind of tried to convert that into a Docker container, and we were able to run it and get the same results as we got with the Python, right? But the cool thing about this is, if you go down here, the cool thing is that if you go down to a Docker container, right, you basically now have all the images, right, which you can just push at the click of a button, and someone else can kind of pull it and kind of run the container within like probably 10 seconds, right? And they don't have to sit and kind of download Linux and download Python on it and download the dependencies and everything, right? You can package everything inside a container and share it. So it basically helps with the portability of code, and packaging it becomes very, very simpler. It's a really great way to create MVPs, right? You want to create a quick POC, Docker is a very easier way to do that, right? Again, don't use Docker wherever it's not necessary. If it is necessary, if you want to create something like this, I would say it's a good thing to explore, right? Thanks for watching, guys, and have a good one. Bye.